Let's go to Math 116. Let's get into the notes real quick. Okay, let's talk about R.2 here. Okay, not to be confused with R2 D2. Yeah, I just had to do that. Sorry. Okay, it was a must. Anyway, so let's go over R2, which is a functions and models. Okay, functions and models. So R.2. Functions and models. Okay, so we're going to deal with models of cost, models of profit, models of supply, models of demand. We're going to go through all of those things. So we need to know what's a function, okay, and how do we deal with functions and linear and quadratic models. Okay, so what's a function? Okay, definition of a function, okay, is a correspondence, okay, between, okay, a first set, okay, called the domain, that's what you get for teaching from home. Go back to your room, little girl. Okay, called the domain, and a second set, okay, called the range, such that each member of the domain corresponds exactly once, corresponds to each member of the domain corresponds to exactly one member of the range. Okay, so what does this mean? It just means that your X values have to be unique. Okay, your X values have to be unique. Okay, that's what this means to be a function. Okay, you have to have unique domain values. Your domain cannot overlap. Okay, so you cannot, you know, it's like social security numbers, right? You can have, you know, one person has one social security number. It's unique to each individual, right? So you think about how I want to explain this. So you have to have different people, okay? Right. So each social security number, let's say that we have 111-111-111. Okay, so there's somebody's social security number, right? And that guy's social security number, his first name is Rob, right? His first name is, we'll say, Robert. Okay, and then I have social security number 222-222-2222, but his first name is also Robert. Now, because the input is unique, I don't have a problem. The output doesn't have to be unique. We could have two different social security numbers, both go to a guy named Robert. Now, hopefully the person has a different last name, okay, or different middle name. But even if they don't, even if they were both Robert Smith, right? Even if those social security numbers were both Robert Smith, it doesn't matter. It's still a function because the inputs are unique. Okay, does that make sense? The input values are unique. The input values cannot be, you can't have a social security number like 333, 333, 3333 map to two different people. This is Sean Smith and this is Robert Smith. Does that make sense? That doesn't work. You can't have that. Therefore, this relationship is not a function. Why? Because you repeated your input twice. Yeah, it's a relation, exactly. Exactly. This is not a function, it's just a relation. Okay, so this is my input, this is my output. Okay, so only a function if for every input you have a unique endpoint. Okay, and generally in this class, where our unique input is time, and since we cannot go forward or backward in time, all of our domain values are unique. So if I said, oh, what's f of t, right? When I have, say, 1,000 times 1.07 to the t power, we'll do 100, right? Is this a function? Well, yeah, because the time, all the time values are unique, right? So for t equals time, the function is unique. It's a unique function, right? All the input values are unique. Now can I have output values not be unique? Sure, I could have output values not be unique. I could make $2 on March 5th, 2005, and I could make $2 on March 7th, 2009. It doesn't matter that the outputs are the same. What matters is that the inputs are different. Okay, so that's the main idea there. Since this isn't a pre-calc class, I'm not going to go too deep into this. Okay, so f of x, okay, is a function, f, a function of x. Okay, f, a function of x. Okay, we also call it f of x, just for short, f of x. Okay, number one, f of x equals x squared. What's this guy look like? Well, this guy looks like a parabola. It's our parent function, f of x squared. That's our nice parabola there that goes through the origin. Okay. Move this up real quick. There we go. Okay, let's evaluate this function. Okay, so f of -3, what would f of -3 be? Well, that would be -3 quantity squared, which is 9. Okay, so at when x is -3, y is, or the output is 9. Okay, so what about b here? B, what about f of 1? What's f of 1?
1.
1, yeah. Feel free to post your answer in the chat as well. Thank you, Gabriel. Okay. Okay, 1. Okay, well, C, let's see who knows this one. What's f of k? Okay, f of k. What's f of k?
K squared.
Yes, very good. Thank you, k squared. Okay. We don't use u in this class. Okay, there's a reason we don't use u, because then you'd end up saying, what's fu? Yeah, that's probably pretty bad. Okay, so don't.
Did you say it?
Just don't do it. Okay, because your mom will smack you. Okay, you'd be like, Mom, I'm just doing math. Okay, I didn't say that. Okay, here's a true story. Okay, true story. Hey, oh, it's a good story because it's about my daughter too. This is her 16th birthday tomorrow, so this is a good story. Okay, So I've actually taught I've taught online. I taught online for 5 years straight. Okay. And so back then we didn't have tablets. So what I had a big whiteboard right up here, and I would actually lecture in front of the whiteboard over webcam. So that was how I lectured, right? So now I have a Surface Book 3 that just came out. So I'm very poor right now, but I have the technology that I want. So I run a desktop and a Surface Book 3 simultaneously. And so so I was giving a lecture, and my daughter was in the other room, and I hear her yell out, "A butthole." She was like 3 at the time. Right? I was teaching from home so that I could stay at home, right? So she's like, and then I heard it again. She says, "A butthole." And I'm the only one home, and she's the only one home. So why is my 3-year-old daughter in the other room yelling out and saying, "A butthole"? And I had to stop. I said, "Students, I have to stop class. I need to go see what's going on with my daughter. Why is my daughter cursing in the other room?" Right? And she's watching TV right now, and she's watching Dora the Explorer. And she says it again when I walk in the room, "A butthole." And I'm like, "What? What did you just say?" And she's like, "It's Dora." And I said, what's up with Dora here? And she says, "Dora's going under the bridge."
Uh-huh.
I think you Spanish speakers just got it, right?
Yeah.
Yeah, exactly. It's a bajo.
Uh-huh.
A bajo. Here I thought she was cursing, right? And is going under the bridge with her little, monkey and with the red boots and the guy that keeps stealing all our crap.
That's Swiper.
Swiper, right? Swiper. Yeah, what are we teaching kids? To be thieves? And all you have to do is give the stuff back? Like, oh, I shoplifted because I saw Swiper on TV. That's a good morality lesson there.
You didn't say Swiper, no swiping.
Sorry. Okay. Anyway, I digress. So we don't say F you in this class, okay? F of you. You'd be like, "Hey, Mom, F of you." Okay? So, yeah, exactly. Okay, yeah, okay, so what are we gonna, let's do the next one here. D. Okay, D. F of radical K. Radical K. Okay, F of radical K. What's this going to be? Yeah, exactly.
K.
Just K. Okay, because we're going to do radical K squared, and then it's just K. Okay. Okay. So, sorry, this is in my eye. Okay, E. Like it's your finger, dude. Yeah. Okay, what about F of 1 plus T? What's this one going to be? F of 1 plus T. Well, let's see what we get here. We're going to go 1 T squared, right? 1 plus T squared. Okay, we were going to FOIL this out. That's going to be 1 plus 2T plus T squared, right? After we FOIL that bad boy out, right? Oscar, is that right? We're going to FOIL this guy out. Does that make sense? And we get the 1, and then we get a T plus T, which is and then we get a T squared, right? Okay. Okay. F here, what's F of X plus H? What's that going to be? What's F of X plus H? Well, that's X plus H squared, which is what? What does that end up being? How about X squared plus 2XH plus H squared? Does that work? Okay. Thank you, Gabriel. Okay, what's your major, Gabriel? Your major is math? You're taking business calc? Why are you taking business calc? There's a story behind that. You're a math major taking business calc. Okay, it's all good. What was A? A was 9. -3 squared is 9. Oh, you need the refresher. Oh, okay. That makes sense. Okay. Let's look at number 2 here. Okay, number 2 is A is f of 0. Okay, f of 0. Well, let's do f of x first. Tell you what f of x is. We don't know what f of 0 is. So we do f of x. F of x is equal to 3x squared minus 2x plus 8. Okay, minus 2x plus 8. Okay, A. Okay, f of 0 is equal to 3 times the 0 squared minus 2 times 0 plus 8. Everything goes to 0. This goes to 0. That goes to 0. And so we're just left with 8, right? Okay, so just equals 8. Okay, what about B? Okay, let's try -5. F of -5 is equal to 3 times -5 squared. Now make sure that you're squaring the negative as well. Minus 2 times -5 plus 8. Okay, what does this become? This is going to be 3 times 25 plus 10 plus 8. Okay, so this is going to be 75 plus 10 plus 8. When I add that together, that's going to be 85 plus 8, which is 93. Okay, let's do one last one here on this. Okay, what would be f of 7a? What would be f of 7a here? F of 7a, well, let's see what we get here. 3 times 7a squared, okay, minus 2 times 7a plus 8. Okay, 7a squared, that's 7a times 7a, which is 49a squared. So this is 3 times 49a squared minus 14a plus 8. Okay, it's 14a plus 8. Okay, 3 times 49, that's going to be 150 minus 3, which is 147. Okay, a squared minus 14a plus 8. That's what that is. Okay. Let's see what else we got here. Okay, let's do one more. Let's do one more of these because this is getting boring. Let's do number 3. Okay, f of x is equal to x minus x squared. Okay, so let's plug in a 4. What's f of 4? What's f of 4? Any ideas? Okay, can we get a fraction example? Possibly.
Is it 0?
Is it 0? F of 4? No, it's not 0.
-12.
Yeah, -12. Why -12? 4 minus 4 squared, that's going to be 4 minus 16, which is -12. Okay, thank you very much, Justin. Okay, everybody else that got the right answer. Okay, what about B here? Let's do f of x plus h. Okay,
Is the negative 12?
yeah, it's negative 12, thank you. Okay, f of x plus h. Okay, that's going to be x plus h times or minus x plus h squared, right? X plus h minus x plus h squared. Well, we already saw what x plus h squared was. We already know what that is. That's x plus h minus x squared plus 2xh plus h squared. We already did that. And so I'm going to distribute the negative sign. I get x plus h minus x squared minus 2xh minus h squared. Okay, okay. And so how can I rewrite this? Well, how about a x? That's about it. That's about it. I could put it in descending order if I really wanted to. I don't want to. I'm just going to be happy with this right here. Okay, I can leave it in any order that I want. And so we're going to leave it like that. Okay. So let's do C here. Let's do C. Let's do f of x plus h minus f of x all over h. Ooh, getting spicy, getting spicy. Okay, we're spicing it up. Okay, spicing it up. Okay, you can blame Gabriel for that one. Okay, so just make it spicy. Give it some, add some chorizo. Okay, that's just spice it up. Okay, so f of x plus h minus f of x. Okay. Yeah. So what was, well, we already know what f of x plus h is. Didn't we just calculate that? We just calculated that, right? Oh, okay. So this is x plus h minus x squared minus 2xh minus h squared minus f of x, right? Minus f of, okay, minus f of, well, what's f of x? Well, f of x is just my original function. X minus x squared all over h. Oh, okay. Okay, let's see if this cleans up. Okay, let's see if this cleans up. Well, I'm going to distribute my negative sign there. Nice, nice, nice. I'm going to go x plus h minus h squared minus 2xh minus h squared minus x plus x squared. If I write too fast, let me know. Just say, you know, whoa, or slow down, or bro, I can't write that fast. Okay. Don't call me bro. Just say, professor, please slow down. Okay. Because I ain't your bro. Okay, I got two bros already. Okay, one's a professor at Columbia University in New York. The other one is an airline pilot for United. Those are my two bros. Okay, so yeah, let's see what we get here. Let's see what we get here. Okay, Giselle says, well, let's see if we concur. Okay, let's get rid of some like terms, right? Let's get rid of some like terms. So x minus x, that's gone. Oh, look at this. The x squared and the x squared, that's gone. And so the only thing that's left over are terms that involve x, or sorry, involve h. Right? That's an h, not an n. Not to be confused with H1N1. Sorry, I had to say it. Okay, so Okay, so I'm going to factor out an h now from the top. So this becomes 1 minus 2x minus h all over h. Cancel out the h's. And then this is equal to 1 minus 2x minus h. Boom, nice. That is some good math right there. Okay. Right. And what happens if what would happen if h was equal to 0? What if h was equal to 0? Then what would we get? We get 1 minus 2x. Right? What was the original function? Well, the original function, f of x, was x minus x squared. Yes, exactly, Oscar. Yes, you're very true. What was the original function? Wasn't it x minus x squared? What we're going to see is there's going to be a relationship between these two later on. This is going to be f prime of x. Okay, but that's kind of a preview of coming attractions. Okay. Okay, so there's a relationship here between these two. So, yeah. Okay. Okay, does anybody know what the vertical line test is? The vertical line test for functionality? Vertical line test. That's if you graph a function. If I graph a function and if I'm able to have a vertical line pass through this function and it doesn't ever cross itself twice, then it's a function. It's called the vertical line test. Okay. You can also call it the ruler test. Okay, but you can have rulers that go either way. Okay, but I'm gonna stop. Go back. What I did here. Okay, so if I make the ruler 90 degrees, 90 degrees, I said 90. Will you stop? Behave. Oh, behave. Okay, 90 degrees, right? So if I take this ruler and I pass it through at 90 degrees, if I pass the ruler through, it will only touch the function once. Therefore, this is a function. You, sir, are a function. Check. Okay, you, sir, are a function. Okay, what would not pass the vertical line test? Well, remember the parabola that we had the other day, x equals y squared? Remember this guy here? Is that a function? No. You, sir, are not a function. Not a function. We're not a function. Okay. Okay, what about y equals x squared? Is that a function? Yep, that's a function. Any equation solved for y, any equation solved for y is a function. Okay, this is Holtman's rule. There. It's my rule. I claim it. Okay, it's unclaimed. So I'm just going to put my name on it. It's my rule now. Any equation solved for y is a function. Boom, proven. There you go. QED. Okay, there you go. Okay, nobody claimed it, so it's mine. Okay. Okay, let's talk about something called a piecewise function right now. Okay, what's a piecewise function? Well, it's a function that is in pieces. You guys hear me okay? Oh.
It's frozen.
Testing, testing, 1, 2, testing. There we go. Okay, perfect. Okay, so piecewise function. Okay, we're going to look at the function. We'll look at A here, number 5. Okay, we want to graph these guys. Okay, graph this function here, f of x is equal to, okay, 4 x is less than or equal to 0. So if it's negative, then the function is just 4. Okay, and then 3 minus x squared, okay, for anything bigger than 0, okay, for x is greater than 0. Okay, so how are we gonna graph this guy in pieces? Well, it depends on where we land in our domain. Right? So what's the line y equals 4 look like? What does the line y equals 4 look like?
Horizontal.
Yeah, it's a horizontal line, right? Thank you. Okay, horizontal line. Okay, so if we're up here at 4, 1, 2, 3, 4, that's just going to be a horizontal line at 4, right? Y equals 4. But this is only valid where? This is only valid when x is, okay, when x is, oops, my white one. Okay.
Less.
When x is negative, right? When x is negative. And can it be 0? Can x be 0? Am I okay if x is 0? Am I still on the line y equals 4? Yeah, because of this
Yes.
inequality here. Yes, thank you. Okay, yes. Because of the inequality, I am okay. So I'm gonna put a solid dot here, saying that it is included. Okay, the endpoint is included. Okay, and then I'm going to put a little arrow that says, hey, everything, okay, to negative infinity is okay as well. Okay, so we're good. We're good with that. Okay, now what about this 3 minus x squared? How does that play into things? Well, let's plot some points on 3 minus x squared. So when x and 3 minus x squared, right? Let's plot some points here. Well, if x was 0, what would we get? We would get 3. However, we can't have that value, but we can have everything close to that value. So I'm going to put a open circle at 0, 3. Okay, open circle at 0, 3. Okay, what about 1? What happens at 1 here? Well, 3 minus 1 squared is 2. So that goes down to 2. Okay, what about 2? This is going to go down to negative 1. Right? So at 2, we're now down at negative 1. And this is kind of half of a parabola. Right? So that just keeps going forever down. So we jump from a line to a parabola. And where do we make that jump? We make that jump at 0 when x is equal to 0. Okay? So when x is equal to 0, we have a jump. This is called the discontinuity. It's discontinuous. Okay, it's called a jump discontinuity. You don't need to know that, but It's just extra. That one you don't pay for. Okay. You pay for the math. You don't pay for the jokes or the extra stuff. Okay. Okay. Those are just bonuses. Okay. Let's try the next one here. Let's do B here. Okay. Let's say that g of x is equal to, okay, what? Okay, 3 for x equals 1, and it's equal to negative x plus 2 for x not equal to 1. Oh, okay. So it's negative x plus 2 for x not equal to 1. Okay. So everything except 1, 1 seems to be like a bad point here, right? Seems to be like a bad point, but everything else other than 1 works. And it's on this line, right? So it's the line y equals negative x plus 2. Well, how do I graph the line y equals negative x plus 2? Well, that's a y-intercept at 2. Okay, so I know that from algebra. I know that it's a y-intercept of 2. And then it's a slope of 1, right? So I'm going to go down 1, over 1. Down 1, over 1. I can do that twice. Down 1, over 1. Oh, okay. And then I'm going to grab my ruler here, and I'm going to graph my line. Okay. So let's graph my line there. Okay, and so that's the line. The problem is what? The problem is when x is equal to 1. The problem is that what value is the function when x equals 1? It's not 1, right? It's not 1. So what I'm going to do here is I'm going to put an open circle. I have a hole right here. Okay. Okay. I have a hole right here. It's not a bajo. It's a hole. Okay, in my graph. It's a discontinuity. Okay, it's a discontinuity. And so what at 1, when x is equal to 1, where is that discontinuity? Where is that point? Where does it jump to? Yeah, thank you, Justin. It jumps to 3. So there is one singular bad point here at 3. Okay? That is the point 1, 3. Okay, let's talk about domain and range. Okay, so that's R2 right there. That's R2D2 right there. Okay. If those points overlap, is it continuous? Yes, absolutely, Gabriel. It is. Okay. And if all the points behave like that, that's a proof of continuity. Okay. We'll talk about continuity a little bit later. Okay. So R.3 is finding domain and range. Finding domain and range. Domain and range, right? Domain and range. Okay, so let me get rid of the ruler. I don't need that now. Finding domain and range. Okay, so what's domain and what's range? What's domain and what's range? Oh, okay. Well, think of the domain as my input values. Okay, think of the range as my output values. Okay, and if it's a function, what did we say that the domain was if it's a function? The domain values
X.
must be what?
Unique.
Unique. Yeah, unique. There's like, which is a very popular name amongst the Black community, is unique. And did you know there's over 200 different ways of spelling unique? Think about that for a second. Yeah, because all the uniques want to be unique. It's interesting. This is true. You can Google this stuff. Okay, I don't make this stuff up. Okay, so the domain values must be unique. Okay, must be unique. Okay, so domain values must be unique. Okay. Okay, if it's a function. So how do we talk about domain and range? Well, let's look at our pizza machine here. I like pizza. Pizza's good. I kind of live off of pizza. I have pizza at least once a week. So here's the burners, right? Okay, the fire. Here's the little conveyor belt for my pizza, right? And so the uncooked pizza, that's my domain. The warm and gooey, cheesy goodness that comes out of that pizza oven, okay, that is the range. Okay, that's the range there. So the domain are what goes in the pizza oven, and the range is what comes out of the pizza oven. And in the pizza oven, we're going to say that for this pizza oven, the burner is 2x plus 5. That's the burner. That's the function. That's f of x. And the burner, this is the action. This is what happens to my anchovies. I don't put anchovies in pizza. That's disgusting. People should be put on medicine or something. Put fish on pizza. It's disgusting. Okay, so what the domain is, say that we had a domain of 1, 0, 1, 2, and 5. This is the domain. What would the range be? What would the range come out to be? Well, if I plug a 0 in, what comes out? 5. If I plug a 1 in, well, what comes out? A 7. 9. Right? And then a 15. Right?
Yeah.
So that's my domain, and that's my range. Make sense? Good stuff. It's all good. All good in the hood. Yeah. Okay. School's in session. Someone's gonna be taught a lesson. That's all I have to say. Okay. Yeah. Okay. Let's get to work. Okay, number 1. Find the domain and range, okay, of the following function. Find the domain and range for f of x equals the absolute value of x. Okay, absolute value of x. Interesting. Okay, what can my x's be? Are there any restrictions on what x can be here? Is there any restriction on what x can be?
No negatives.
I think you're confusing the domain with the range. Okay, they can't be imaginary. That's true. We want real numbers, all real numbers, right? Okay, so we don't want imaginary numbers to be in here for x. Okay, we just want real numbers. So we could represent the domain a few ways. We could represent it as all real numbers with a script R. This is a script R, meaning all real numbers. Okay, all real numbers. Okay, we could write it as in interval notation. The domain goes from negative infinity to positive infinity. That's interval notation. We could also do it in set notation. Okay, set notation. Set notation looks like this. It's a little fancier. The domain is, we use these curvy brackets. Anybody know what those curvy brackets are called? Nobody ever does. They're like, why would we study that? Okay, you're just, only nerds study that. Okay, oh my gosh, Oscar is a nerd. I say that with the most humblest of admiration for Oscar because it's called a brace. Exactly, they're braces. Yes. He's like, it's computer science, bro. I'm geeking out with Oscar right now. Showing Oscar the love. Okay, so, okay, they're called braces. They go on your teeth, right? They go on your teeth. They cost thousands of dollars. Okay, hundreds of thousands of dollars. No, I'm just kidding. Okay, it feels like that. Feels like that. Every month, paying for more braces. Okay, so they're called braces, exactly. So this says that x such that this little line means such that. Okay, it's all values of x. All values of x such that x goes from negative infinity to positive infinity, and then we close our brace. Okay, so we close our braces there. Let me move this over. Okay, sound good? Look good? That's the domain. Okay, well, what's the range? What's the range in this case? What's the range? What does that absolute value do? Somebody said this earlier. What does that absolute value do? It makes everything
Positive.
positive. Thank you. Thank you. Who was that? Giselle?
Yeah.
Okay, good job, Giselle. Okay. And so, so yeah, what is the range here? The range goes from 0. Can we have 0? Sure, we can have 0. We can have 0, but in interval notation, it would go from 0 to infinity. 0 to infinity, and we always let infinity be a parenthesis because we can never get there. We can never get to infinity. Okay, so that's the range. So domain. We could do interval notation on both of them. You just want to be consistent. Okay, so domain is from negative infinity to infinity, and the range is from 0 to infinity, and 0 is included. Okay, let's try one that's a little spicier. Okay, I used to say a little harder, but then it made people sad in my class. So I don't use the word harder or more difficult. You know, I really want to, you know, boost people's, make themselves not feel bad about themselves, you know. So we don't use the word harder or more difficult. We use spicier. I don't know. People like spicy food. Okay? People like the spice. You know, put a little jalapenos on there. We're good, right? It's all good. Right? So spice it up. Okay, let's make it a little spicier. Okay, number 2. Okay, find the domain and the range. Find the domain. If I can write. Find the domain and range of f of x is equal to 3 over 2x minus 5. Okay, so one of the properties of mathematics is that we cannot divide by 0, right? Division by 0 is not allowed. Okay. Not allowed. Division by 0 is not allowed. Okay. That means that I can't let the bottom be 0. So I can't let, what value is going to be a bad value? Well, It's the value that would equal 0 here. So let's just solve for x. We're going to go add 5. 2x equals 5, and then divide by 2. Cut 5 in half. Oops, 5 in half. And yeah, x equals 2.5. So x cannot equal 2.5. X cannot equal 2.5. It's not allowed. Okay? Since the denominator cannot equal 0, x cannot equal 2.5. Okay, so how would I write that as the domain? Well, the domain, okay, would be from negative infinity to 2.5, and then I use a union symbol, okay, a U, union symbol, and then 2.5 to positive infinity. It's just that one value I have to get rid of. I have to get rid of that one value. This is how we do it. Okay, what about the range? What about the range? Are there any values that I can't have in the range? Any ideas? If I can't have 0 in the denominator, well,
You can have imaginary numbers.
I can't have what? Negative numbers?
Imaginary numbers, negatives, or
Okay.
zeros.
I can't have imaginaries. Yeah, we're not going to really talk anything about imaginaries in this class, so that's completely off the table. Okay, but is there a real number that I can't have for the range?
Is it 2.5?
No, I can have 2.5 for the range. All right, can I have 2.5? Sure. 2.5. 2.5 is that equal to 3 over 2x minus 5. If I were to cross multiply, I would get 2.5 times 2x minus 5 equals 3. I could solve for x easily here, right? So I can have 2.5. Okay, Justin says we can't have 0. What? Yeah, why can't we have 0? Why can't we have 0? There.
That would make never mind.
Well, there's no way to get it, right?
Yeah.
There's no way to get 0 because of the way the function works. So we cannot have 0. Right? So, oh, okay. So that we can't have 0 here. Okay. So I'm going to go negative infinity to 0, because if I can't have 0 here, and this has to always be a positive or negative number, when I take 3 and I divide by a positive or negative number, won't that always be a positive or negative number? It's never going to be 0. Does that make sense? So I can get as close to 0 as I want, but I can't ever get there as a result. So this is negative infinity to 0, unioned 0 to infinity. Okay, so that's my range. If you were to graph this function, it would look like this. Okay, it would look like this. What do you think? Where do you think this horizontal line is at? Sorry, this is. Did I
2.5.
graph that wrong? Sorry. Let's try it over again. It's the domain that's at 2.5, not the range. Sorry. So we've got this guy going, and this guy going, and this guy, and that guy. Okay. And so this guy is x equals 2.5. Can't have 2.5 there. Okay, and this guy is y equals 0. Okay, can't ever have y equals 0 either. And you know what those are called? You know what those are called?
Asymptotes.
Yeah, don't make an asymptote out of yourself by getting the wrong answer. It's not a good idea. Okay, just don't do it. Don't you know, don't look at the asymptote on that mother function.
Professor, can you explain how you got to the range? Those
The
I
range,
thought, yeah, because you said that we couldn't have any negatives in the bottom.
no, you can have negatives, yeah.
Wouldn't that?
Have zero. You can't
Oh,
have zero
okay.
in the bottom.
You just can't have zero because it would make it a negative in the denominator.
No, you just can't
No?
have zero. You can't have zero in the denominator.
Oh, okay. So
Okay?
then that's okay. I understand. All right. Thank you.
So you can have any other number, and if you divide the top by any other number, you're never going to get zero for an answer.
Okay. Thank you.
So it's off the table. Okay, let's try another one. Okay. Consider, number 3, consider, okay, the function a of t is equal to 500 times 1.00625 to the 4t. Okay, so compound interest here, right? Compound interest. What's the principal? What's the principal?
500.
500, yeah, principal is 500. Okay, so the principal is $500. Initially invest $500. How many times am I compounding this in a year?
4.
Yeah, 4 compound, n is equal to 4. Okay. And I could multiply this 0.00625 times 4, okay, to get the interest rate, the annual interest rate, and that would be 2.5%. That's R. Okay. Dividing this by 4 is going to give me that 0.0625. Make sense? So we worked a little backwards. We're going to consider this. This is our compounding. We're compounding quarterly, right? We're compounding this quarterly at 2.5% interest, annual interest, compounding 4 times, and I can find out how much money I will have made after a certain number of years, right? Time is in years. T is time in years. Okay. Okay, let's find the domain of this function. Find the domain of this function. Okay. Okay, so what would be the domain of the function? Well, can the domain be negative? Can the time be negative?
No,
Why?
because you can't have negative years or negative money unless you owe.
Okay, so if you owe money, then you can have negative money. Okay, can you predict what happened in the past based on current events? If I said time was now at 2020, and based on the interest that I'm making currently, could I go backwards and see what my bank account would have had 4 years ago? Can I let time be negative? Well, yeah, I actually can. Okay, so I can let time be negative. Oh, okay, so it's okay. So what's the domain here? What's t? T is going to go from negative infinity to infinity. Okay, I can go forwards in time as a predictive model. I can go backwards in time as a model that tells me what occurred in the past. Okay. Okay, so we can let time be negative. So this is an exponential function, right? So this is an exponential function. So at time equals 0, where am I at? Where should I be at time equals 0? Yes, it refers to the x. What can the x's be? Yes, Oscar. So at time equals 0, how much money do I have in my account? At 2020, okay,
You have $500
exactly.
in the account.
That $500, 500 smackanolies. Okay, and so this is an exponential curve. I'm going to try to rewrite that a little bit better. Ah! Knew that was going to happen. I don't think I can get rid of this file without getting rid of the whole thing. Okay. Okay, so this is an exponential growth curve, right? Exponential growth curve. Okay, so is there any value of t that is not on this curve? No, we can have all of them. What about the range? Is the range, can I have any y value? Can I have any y value? Can I let the initial investment be negative?
No.
No. And what happens if I start with $0?
You get 0 interest.
I get $0. I can give you nothing. I can invest nothing with you. I can invest nothing with Alex. I can invest nothing with Yusuf, and I'm still going to get nothing, right? You get nothing, and you get nothing, and you get nothing. That's my rule. Oprah thing there.
That was
Okay.
the opposite. That was the opposite of Oprah.
Yeah, exactly. You get nothing. You get nothing. I can hand out nothings all day. Okay, no sweat. Right? But if I go to the bank and say, hey, I want to invest $0, they're going to be like, okay, and you get 0 interest. Right? What if I invested negative dollars? Well, that's called a loan. Right? Now you got negative interest. So you're paying the bank. Right? So no, I don't want to invest negative dollars, and I don't want to invest $0. I only want to invest positive money. So what's the range here?
0 infinity.
Is 0 included? Is 0 included? Am I going to want to invest $0? No,
No.
it's not included. Okay. But again, if this was $500 at 2020, could I find out based on the current interest rate? Could I find out what happened in 2018? Yeah, I could. I could go backwards in time. That is allowed. Okay, but what is not allowed is to invest negative money to make a profit. Okay, that would be a no risk investment. Do you know what? Does anybody know what a no risk investment is called?
No.
No.
No. 0 risk investment is called arbitrage, and it's illegal. You can't
Certificate
have
of deposit?
0 risk investment. What?
Yeah, certificate of deposit.
Well, we're not talking about. We're talking about like in the stock market. Okay? You can't have 0 risk in the stock market. Otherwise, it's called arbitrage. Okay? 0 risk. Okay. There has to be some risk in order for you to make money. Okay. The only thing that is basically 0 risk is, you know, something that's insured by the federal government. But that's not even guaranteed, is it really? You think about it, right? Yeah, they're giving you, the federal government's giving you, that's the FDIC, right? So the federal government's giving you a insurance on what the bank owes you. However, what happens if the federal government goes bankrupt or we're invaded and we're taken over? How good is your federal deposit insurance then? Doesn't exist. So there really is not a 0 risk. If you have a 0 risk investment, you're ending up with something that's illegal. It's called arbitrage, okay? And it's in derivatives and stocks. I've studied derivatives in college, so the derivatives market, not derivatives math. I studied that in college as well. Okay, but I also studied derivatives market, puts and calls puts and calls and all this stuff. Okay, selling stock short and all that. Okay. Okay, can you explain to me why 0 is not included? Yeah, because okay, we cannot have 0. That we can't go backwards forever and get to 0. Okay, now why is that? Why can we never go backwards and get to 0? That's a great question. Why can we not do that? Let's look at our function here. A of t. Okay, A of t. Let's say that A was equal to -2. Let's say that t was equal to -2 years. Okay, so what's going to happen here? -2 years, right? So in -2 years, would we get $0 in our account? Right? Could we start with money? Could we start with something and go back enough in time to where we get nothing? Can we go far back enough in time to start with something where we ended up with nothing? Now we could start with 1 penny, and after 2,800 years, we could have $500, right?
Yeah.
Right? We can start with 1 penny, but we have to start with something. Right? We have to start with something. If we start with nothing, we're going to get nothing. Does that make more sense? The other way that you can make it make sense is this. Okay, let's say that we have -2 years, right? And we say, oh, this is $500 at 2.5% interest, compounded 4 times a year, and we're going to put -2 in here, right? Here's the question: does a negative exponent make the number negative? No. It just makes it go into the denominator, right? Doesn't this now become 500 over 1.000625 to the 8th power? So what did we just do? We ended up dividing now, right? So we're going to take our $500 and we're going to divide. Well, can I ever take a number, a positive number, divide it by another positive number and get 0? No, no matter how big that positive number gets. As this number goes up, what happens to the whole thing? It just goes down, right? But does it ever get to 0? No. Does that make sense? So even if you had 10,000 years in the past, right? What would this be? This would be 40,000 years. Would I ever get to 0? No, I get really close. Okay, so close that you would have basically nothing, because it would be less than any monetary value that you could come up with. But the math won't allow you to go to 0. Does that make sense? Does that help? Hopefully. Okay. Can't get there, because if we could, we would be making money off of nothing, and you can't do that. You can't get something for nothing. Not in this book. Okay, maybe in the next one. Not in this one. Okay, last problem. Okay, we want to consider something called the greatest integer function. Okay, I'm going to make this smaller. Move this over. Okay, consider the greatest integer function okay, g of x is equal to, and we have double brackets here, this. Okay, so we want to find the domain and the range. Okay, give the domain and range. Okay, so give the domain range. Consider this guy. Okay, give the domain and range. Okay, so what's the greatest integer function? Well, here's how the greatest integer function works. It says that for any value that you can think of, give me the greatest integer of that value. For example, let's let x be 1.5. Then what would be the greatest integer that we had gotten to? The greatest whole number. What's the biggest whole number that we would have gotten to?
1.
I wanted to say, how many whole dollars do I have?
1.
Yeah, I have one whole dollar, right? I have one whole dollar, so that's 1. Okay, what about 2.78? What's this guy? Okay, thank you, Oscar. 2. Very good. Okay, thank you, Paul. Okay, 2. Okay, and then what about 3.45? What's that one gonna be? 3, right? Okay, what about 2.095? What's that one gonna be? Is that one gonna be 2? Right? Yeah. Thank you, Darlene. Okay, that one's gonna be 2. So when we look at this function, and we'll talk about, you know, what, let's do one more. Let's say that we have 0.43, okay, or 0.43. How many whole dollars do I have?
0.
Yeah, 0, thank you. Okay, 0 whole dollars there. Okay. Okay, so here's what this function looks like. Okay.
Professor, so this function rounds all the numbers down to whole numbers.
It doesn't round, we don't round, it just cuts them off, it truncates. Okay, that's the word is truncating.
Okay, thank you.
And so, let me get rid of this too. Okay, so here's the deal on this one. So at 0, we have $0. Does that make sense? 0 is 0. 0 is 0. Are you good with that? 0, 0. $0, 0 whole dollars. Okay, 0, 0. So I'm going to put a dot at 0, 0. And then at 0.43, let's do 1, 2, 3 here, and then we're going to do the negatives. 1, 2, 3. The negatives are a little spicier. 1, 2, 3. Okay, and so as we go all the way up, even up to 0.43, we're still at 0, right? But what happens as soon as I hit 1? Then what's the next integer? 1, right? So what I do is I put an open circle here. And then I jump up As soon as I hit 1, aren't I at the next integer? Aren't I at 1? And so this is called a step function. It's a step function. Why is it a step function? Because it looks like stairs. That's called a step function. Okay, it goes like this. And then once I hit 2, I'm at the next integer, right? And then once I hit 3, I'm at the next integer. Make sense? Okay, and it just kind of goes up forever. Good? Okay, now let's talk about the negatives, because the negatives are a little more confusing. Okay, what if I had negative 1.43? Negative 1.43, what does that mean? Negative 1.43. What's the greatest integer that I would have achieved from negative 1.43? Any ideas? What's the greatest integer that I would have achieved for negative 1.43? It's actually negative 2. Okay. And you're like, what? That doesn't make any sense. Why is it negative 2? Because have I made it to negative 1 yet? Now think about a number line, right? Think about on a number line. If I'm here at
negative 1?
2, and then I want to go up to negative 1, have I made it to negative 1 yet? No. Why? Because I'm right here. Does that make sense? So what's the greatest integer that I would have gotten to is I would have only gotten to negative 2. Does that make sense? So at negative 1.43 right here, where am I at? I'm at negative 2. Oh, okay. So it should look like this. At negative 2, I'm at negative 2. Okay, that makes sense. But then I stay at negative 2 until I hit negative 1, and then I jump up to negative 1. And then I stay at negative 1 until I hit 0, and I jump to 0. Oh, the pattern continues. It still works. But this looks really weird. Okay, what if I was at, say, negative 2.5? What's the greatest? Sorry, this is a closed circle. At negative 2.5, I would be at negative 3. Oh, okay. So negative 3, negative 2.5, negative 3. Look right there. Okay. Boom. And so we go over, and then we go up. We go over, 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 we go up. And that is the greatest integer function. Okay, so we want to find the domain of this thing. What's the domain of the greatest integer function? What are the x values here? What's the x values? What are the x values for the greatest integer function? Well, is every single x value accounted for? Is every single x value accounted for? And as I go through, let's look at our x values. Is there any value of x that is not accounted for? Well, let's take our ruler here. Oh, I got an x value, I got an x value, I got an x value. Oh, still got an x value. Even though there was a jump there, I still have an x value. X value, x value, x value, x value. Oh, still an x value. Oh, no matter where I put this ruler, I always have an x value. Oh, okay, that's cool. Okay. So what's our domain? Negative infinity to infinity. Oh, okay. Now what about the range? What's the range? Are all of the y values present? Are all of the y values present? Well, look at our outputs here. You notice anything missing in our outputs?
And decimals?
Decimals, exactly. Means if I take my ruler and I flip it on its side, I only get integers. There's huge gaps, okay? It's bigger than the spending gap in Congress, okay? It's huge gaps. Okay, so R is the integers, right? The integers, okay? So we're going to go, okay, and we're going to say that this goes from negative infinity. We really can't use interval notation here. What we have to do is we have to use set notation. Okay, interval notation just fails us. We need a set. We need the set of integers, and we can say, oh, well, this is the integers. Anybody know what the letter for integer is? Other than the one math major in this class? And that's Z. It's Z. It's a script Z. Okay, I didn't expect anybody to know that either. Okay, it's a script Z. Okay, that's the set of integers. Okay, if you wanted to use the set notation, you could just list them out. You could, oh my gosh, my braces are not working. Come on, brace yourself for the comedic stylings of Professor Holtman. Okay, so this is -3, -2, -1, 0, 1, 2, 3, and then it just goes on forever. That's what those dots are there for. It goes on forever. Okay? Any question on anything that we covered today? Y'all good? Please let me know. I'll stick around for a few minutes in case there's any other questions. But at this point, I'm done. Have a good weekend, and I'll see you back here on Tuesday with all of your homework completed. You're welcome. Stop.